Hello everyone, my name is Bhavya, studying CSCA second year in Keshav Memorial College of Engineering. Today, my topic is about speech-based estimation of schizophrenia severity using future vision. Understanding schizophrenia. What is schizophrenia? It is a serious mental disorder which affects a person how he thinks, feels, or behaves, and people may struggle to tell what is the real versus imaginary things. Its core symptoms are confused thinking, means difficulty in organizing thoughts, and unusual speech patterns like speaking in a way that is hard to follow, and hallucinations means seeing or hearing things that aren't there, and delusions means strong false belief. These are some symptoms of the schizophrenia, and it causes through genetics means family history or brain chemistry or environmental factors like stress, trauma, and it can be detected by AL based speech analysis that is work we are currently working on this. Understanding the base research. First, speech analysis. You start with speech recording, convert them into a text format, and then analyze word usage, sentence structures, and irregular speech patterns. And then NLP processing means using natural language processing. In this, its steps included are text cleaning, means removing the noise, and tokenization means breaking into words, and feature extractions means getting useful words. And then comes the pattern detection. In this, we apply machine learning models. In this, models learn pattern linked to schizophrenia, which has disorder sentences, repetitions, and irrelevant responses. Early detection. In this, the main goal is to detect the diagnosis easily. This helps in screening patients, supporting doctors, early treatment, etc. Why this matters, the clinical challenge. First one is difficult diagnosis. Long clinical interviews are taken. The problem is here is time consuming and very expensive and not easily accessible everywhere. Then comes the delayed early detection. Here, easily it is missed. The result, it gives late diagnosis and delayed treatment. Early detection is very important but often missed. Speech contains important clues. Here, patients show how the patterns in speech, like unusual statement structures and disconnect ideas, strange word usage, like indicating of disorder. This connects directly to the and needing for automated support. Here, AI system can analyze large amount of speech data, detect patterns human might miss, and helps the doctor in diagnosis. Project scope and definition here. In scope means what your project does. Here, speech transcript processing means cleaning and preparing the text. And stop word removal means removing common words like is, the, and. And linearization means converting words into base form, like from running to run. And feature extraction using NLP means extracting useful pattern from text. And machine learning classification means predicting whether the speech indicates schizophrenia, and result visualization means showing the output in the form of graph, results, etc. And out of means what your project does not do. First one, direct clinical diagnosis. Here, system does not officially diagnose schizophrenia, only the doctors can do. And the real-time voice recording means you are not building a live microscope system, only using the existing one. And then comes the medical treatment recommendation. The system does not suggest the treatment on therapists. And precision generation means it does not give any medications. Why it matters? Because it detects schizophrenia early, helps patients get better care sooner. And faster detection is the faster the treatment. Helps doctor by giving additional insights and can be used for many people quickly for large scale screening. Proposed solution, it follows a step-by-step pipeline to detect schizophrenia from speech. First, speech is converted into text in the form of transcript. Then, pre-processing is applied to clean the text by removing noise and normalization it. After that, important linguistic features are extracted using natural language processing techniques. These features are then given to the machine learning models, which classify whether the speech indicates signs of schizophrenia to improve the accuracy. Workflow from data to prediction. First one is the dataset collection. Here it collects the speech transcripts, includes schizophrenia patients, control samples, etc. And data preparation means reading data from files, labeling the data, and stored in the structured format. Text tokenization means converting the text into numerical tokens using BRT tokenizer, helps model understanding the language. Then comes the dataset splitting, splitting the data into 80% training data and 20% testing data used for model validations. And model training means training BRJ model learns linguistic patterns, identifying features of schizophrenia. Next comes the model evaluation. The test model performs uses matrices, etc. Model saving means saved trained models are there in this and saved tokenizers and used for further predictions. And prediction process means input new speech transcript and convert them into the token passed to trained models. And the final output is given as confidence score of schizophrenia. Next comes the schizophrenia speech transcript detection. It has three main tiers: presentation tier, application tier, data tier. In the presentation tier, these are the three main, these are the technologies used in this: React, HTML, and SSL. Upload speech transcript means the user can upload a file containing speech texts, and this file can be going to backend, where the presentation tier is the front end. And entire text means the user can manually type text into a input box. This is also can go into the backend by using API layer. And then comes the view prediction result. In this, after processing, the system displays whether the speech indicates schizophrenia or not. View visualization means the output is given in the form of graphs or charts. Then it gives average of probability. And then comes the application type. Here we use technologies like Python, PyTorch, and FastAF, Flash, etc. Here the step one is text processing. Here first one comes that converting lowercase. Here converting lowercase means converting all in normal format, and removing punctuation means removing apostrophe or question mark, etc. Removing stop word words means here we remove is and common words in this. And tokenization means splitting into individual words. Linearization means converting into base form like running to run. This is the text processing. Then comes the feature extractions. Here TF, IDF means importance of the words, and bag of words means count words frequently, and word embedding means convert words into vectors. Then comes the machine learning model, where logical regressions means simpler classifications, and support vector machines means separate data using boundaries, and random forest means multiple decision trees, and LSTM means deep learning models for the text. And this all are combined and given into the probability. And this all goes to API layer, where in this API layer means predict means it returns the prediction, and upload means handles the file upload, and model info means gives model details, and matrices means gives the performance. And this all are given here. Then it goes to the data type, where database storage means storing all the system data securely, and transcript data set means raw speech text data, and proceeded feature data set means clean and transform data is stored here, and train model means here saved ML models for further predications, and evaluation matrices means performing measures like accuracy and FI score. And here, first user inputs the text in the presentation tier. Then the data sent via API through application tier. Then text is cleaned. Then converted into the features. Then ML model predicts schizophrenia. Result plus probability is generated. Result plus probability is generated here. Then the data stored in the data tier, result sent back to into the presentation tier. And users can see the output. User can see here the output. So here the conclusion is we can see the research paper and core concept clearly and understand the system architecture and the flow, and initially pipeline using speech transcript implementation and perform text pre-processing. And further we work on the next step is to work with real audio data sets and improve model to make it more realistic and reliable, and develop a working prototype system and extract advanced speech feature for better accuracy. Thank you.